Hello, everybody, and welcome to hopefully part 2 of my FTC programming tutorial series. All we're going to be talking about in this video is different components that you're going to see throughout a TeleOp program and what kind of the general structure of that looks like. I'm not going to be talking about any specifics, just going to be talking about the general structure and all the components that you're going to need to have when you write your first TeleOp program. I do apologize. I am recording this video no more than half an hour later than I recorded the last video, so my throat is still bothering me. I also do apologize for the convoluted nature of the ending of the last video. As you can tell, I'm doing these without a script, and I'm just trying to do them in one take and see where they end up. I'll most likely end up recording all these videos again in the future once I realize what questions people have, what I'm not answering, what I'm talking too much about. And so these videos will probably get redone, re-uploaded in the future, and hopefully they'll only get better from there. So let's kind of talk about the general structure of what you're going to find throughout a program. So this is my tank drive example that I've deconstructed and deleted parts of, and we're going to go through and add them back one by one. So the very first thing that you're going to see in the beginning of every program is this package line. Now, all this package line is doing is it's telling Java where this file is in the directory of things. So all you're going to need to know is that all of the code that you're going to write should have this org first inspires FTC team code syntax at the beginning of it. And then, so these and what that essentially means is these are all the folders that it's in. So it's inside org, which is inside first inspires, which is inside FTC, which is inside team code. And you can guess this particular file is inside the examples folder of team code. That's all that means. And that's needed at the beginning of every Java file. So the next thing you need to do is you need to do imports. Now, what imports are is it's just including little bits of code from other Java files. Now, in the context of this tank drive example, we only really need a couple of things. One of them is DC motor, which is a container that we use to control a DC motor. And the other thing we need is we need OpMode loops. So we need two things from that. We need LinearOpMode, which I'm going to talk about in just a second, and we need TeleOp. TeleOp is the identifier that's going to tell Java that this is a TeleOp program that you can run and provide inputs to through a controller. And those are the things we need in this particular case. So that's only two imports. This little import star syntax that you see here, where we have this star, all that's saying is I'm going to import everything from this section. I did that originally in this particular example to make it easier to read, because otherwise there would be, I think, 4 or 5 import lines compared to just the 2 we have now. So maybe that's more confusing than it needs to be, but normally you're not going to do this import star syntax. You're going to import exactly what you want. All right, continuing on, the next thing we need to do is we need to make this little class outline. Now, this is where people start to get confused, and that's okay. We don't really need to understand everything that's happening. All you need to understand is this is the class identifier. It's telling Java that this is a TeleOp class that we need to include inside TeleOp. There's some properties that it's going to add to it that we don't need to worry about. The only thing we really need to worry about is it has to be here for every TeleOp program. And the other thing that we need to do is we need to give it a name. You don't need to do this. You can just leave this blank, and all it will do is just give the class whatever name you name it here. But I like to be a little more specific. So this is tank drive example by Brandon. The very next line is, this is our class definition, if you will. Now, you don't need to know what a class is for the purposes of this tutorial. All you need to know is this class is inheriting from LinearOpMode, which is another abstract class that is provided by FTC. And all that means is there's some members that exist within this LinearOpMode class that we are going to be defining, so that first can call our functions for us, and so we don't need to do anything. So all this is doing is providing us basic structure for how we want to get things started, and it's not really doing anything more than that. We don't really need to worry about what that looks like behind the scenes. So once we have that, we have to create this run OpMode function. Now, you don't really need to know what functions are either for the purpose of creating this or programming in FTC. What you do need to understand is this is where your program starts. So the first code is going to look at this. It's going to be like, oh, this is a TeleOp class. All right, where is my start point? Right there? Okay. And then it's going to start right there on line 10. It's not going to, it is going to run other stuff, but for the purposes of this, we don't need to worry about that. All you need to worry about is this is where your program is first going to start. The next thing you need to do, or the next thing that you're going to find people do, is this is where you grab all the hardware you need. Now, you need to have reference to hardware to actually mess with it. So I don't really have like a saying or anything to remember that by. You could probably come up with one. All I'm going to say is, in order for you to change something about the robot physically, you need to have reference to that physical thing in software. And that's all this is. We're referencing a hardware map to get different components. We'll talk about the hardware map in a whole video by itself because it's one of the more important things that we need to know about and understand. But all you need to know is we're taking stuff from the hardware map and assigning it to different variables. So this front left variable is of type DC motor, and it contains stuff from the hardware map identified as left front. That's all you need to know. The next thing you're going to see is the reversing and setting direction of motors. So since this is a tank drive designed and built for 750s robot from the 2022 to 2023 season, only one of these motors is going to be reversed. Now, most of the time you're going to want to reverse two motors because if you think about it, when all the motors are set up on a robot, two of them are going to be facing the same way and the other two are going to be mirrored. And if you want all of them to be rotating in the same direction, you have to reverse two of them. Now, just by the way the chassis is set up for 750's power play robot, you only need to reverse one of them. That's why only one of them is reversed in this particular example, but that's something you'll have to figure out. We'll talk about processes for figuring out which motors need to be reversed in future videos. The next thing you're going to see, now that we've done, at this point of the program, we've done everything we need to do before the actual start of the match. So there's a reason why we do all of this before we get to this line. So this waitForStart line, all it's doing is waiting for you to actually push the play button on your driver station. So once we get to this point, you've successfully pressed the initialize button, and now you're waiting on the play button. So you're waiting for the match to actually be started. Now, we do all of the stuff that we've done up until this point before this line because we don't want to waste any time. If we put the hardware map stuff and the setting direction stuff after this, what's going to happen is whenever we press the actual start button, our robot is going to pause while it actually does all of these things, and we don't want it to do that. It's not going to pause for very long, maybe like 30 milliseconds or something, but it's a pause, and we don't want that. So after the waitForStart, this is where you've pressed the program. So now you're running, and there's two different ways of doing this. So in an autonomous program, what you'll see is you won't see this whileOpModeIsActive loop. You won't see that. You'll see other stuff because autonomous is more of a linear sequence of things that's going to happen the same way every time. Now that's definitely not the case in TeleOp, which is why we have this what's called a while loop. Now all this is it's going to run this particular section of code indefinitely until whatever is within these parentheses is evaluated to not be true. Now this OpModeIsActive, this is a function call. Don't need to worry about what that is. All you need to know is that this while loop is always going to be true until you hit the stop button on your robot controller. That's all that means. So while you haven't hit stop on your robot controller phone and you have hit play, you have hit the start button, whatever code is within these brackets is going to run indefinitely. Now, in the context of tank drive, all that means is we're going to get the left and right stick values, and we're going to put them to the left and the right side motors. That's all that means. So that's all I have to talk about with this particular example. If there's any questions, send me a message or write a comment under this video. We're going to talk about specifics of these things. This is just an introductory example. I know that was fast. You don't need to be able to explain all of these things. We're going to go piece by piece and explain more specifically what each component does and what you need to remember about each one. So thank you for watching, and I'll see you in the next one.